All right, so questions 3 to 6 for extension. Don't forget we're doing every second one of these. Yeah, these columns. Now, log notation is something you haven't really come across before. So I'd just like to revise what we looked at in the video. If I have the log base A of B and it equals C, that means that A to the C equals B. So, for example, and this is the one that people usually like to write, you know how 2 cubed equals 8? Another way of writing that, if we didn't know that it was 2 to the 3 that equaled 8, we could write log base 2 of 8 equals 3. So if you want to color code where things come from, well, A is what we call the base. In this example, it was 2. We would say log A of B, and it's like once the base has been raised to that power, what it equals. And C is the power that it was raised to get to B. So in this example, C was 3. So if we then have a look at x equals log base 10 of 1,000, well, we're trying to figure out 10 to the what equals 1,000. So we could rewrite this as 10 to the x equals 1,000. And you and I both know this, 10 to the x, 1,000, we want them both of the same base. So we're going to go base 10, and 1,000 is 10 to the 3, which means x equals 3. So it's just a shorthand way of writing exponential equations. We can actually put this in our calculator, but we can only put logs of base 10 and base e. We're going to talk about e later. It's a weird number, kind of like pi. We're going to talk about that later. So we've got x equals log base 10 of 1, which means 10 to the x equals 1. Now, 1 is a special case, and it'll always be the same. What is it? Anything to the what equals 1, it's to the 0. Every time you get equals 1 here, it's always going to be 0. X equals 0. Question E, we've got log base 3 of 9. Can you see it yet? That means 3 to the x equals 9. Well, you know 9 is 3 squared. You probably don't need to write this line of working out, by the way. X equals 2. FG. X equals log base 2 of 64, which means 2 to the x comes out as 64. So we're trying to find what 2 was raised to. Well, we know from that list that we did a while ago, 8A, this list, 64. It's 6. 2 to the 6, so x equals 6. We've got log base 8 of 64, so 8 to the something equals 64. Well, you know 64 is 8 squared. So x equals 2. IJK. We've got 12 to the x equals 1 on 12. Every time we've got fractions, by the way, just like we did in the last exercise. I'm sorry, I'm having breakfast at the moment, if you can hear that. We want to make them an index, so that's 12 to the minus 1, isn't it? 1 on 12 is the same as 12 to the minus 1, so x must be minus 1. KLM, we've got 6 to the x equals 1 on 36. Now this is the same as 1 on 6 squared, isn't it? Because 36 is 6 squared. 1 on 6 squared is the same as 6 to the minus 2, so x equals negative 2. And O is our last one, log base 8 of 64. You should be able to see this already. So 8 to the x equals 1 on 64. So 8 to the x equals 1 on 8 squared. 8 to the x equals 8 to the minus 2. X equals minus 2o. You don't necessarily need to do these two lines of working out. I'm putting them in, but you don't have to. Okay, these ones are slightly different. Now we don't know what it's been raised, like we know it's been raised to the 2, but we don't know what it ended up equaling. So for question 4a, we've got log base 7 of x equals 2, which means 7 squared equals x, because it's the number that's here that goes there. So 7 squared is 49. Question C, log base 2 of x equals 5, so 2 to the 5 equals x, so that's 32. Question E, log base 7 of x equals 1, so 7 to the 1 equals x, so that's just 7. G, we've got log base 13 of x equals negative 1, so 13 to the negative 1 equals x, so that's 1 on 13. HI, we've got log base 5 of x equals negative 3, so 5 to the negative 3 equals x, so that's 1 on 125. Because 5 cubed is 125, and 5 to the negative 3 would then be 1 on that. Okay, we've got 2 to the negative 5 equals x. So remember, it's this to the power of this equals this. So that's 1 on 32. That's the last one that we're doing for 4. Rewrite each equation in index form and then solve for x. Remember, a base must be positive and not equal to 1. So this is something we haven't talked about in too much detail. When we do logs, like, you know how when you square root stuff, you've got a plus minus? We're only taking the plus. Sorry, hang on, eating breakfast. Sorry about that. So here, if you've got the log base x of 49 equals 2, that means x to the 2 equals 49. So we square root. So x equals the square root of 49. You don't have to write that step. It's 7. Now, you would think you'd do plus minus 7, but with logs, it's always only the positive. Like, we're very much restricted to that, and we're going to talk about that a bit more later. Okay, log base x of 27 equals 3, so x to the 3 equals 27. So x equals the cubed root of 27, which is 3. I'm going to teach you a way later to do these in your calculator, even though you can't put them into your calculator straight away, so don't stress too much. Here we've got, well, I mean, you could literally put that in your calculator. You know how to put that in your calculator. So here we've got x squared equals 10,000. Is that enough zeros? Yep. So x is the square root of 10,000. You can put that in your calculator, it's 100. G, log base x of 64, which means x squared equals 64. So x equals the square root of 64, which is 8. HI. Here we've got x to the 1 equals 11. Just don't forget, is whatever's here to here equals this. Just a different way of writing it. Well, that's so x equals the first root of 11. It's 11. Okay. If you've got log base x of 1 on 6 equals minus 1, that means x to the minus 1 equals 1 on 6. Don't forget 1 on 6 is the same as 6 to the minus 1, which means we've just got x equals 6. Oh, I don't know what's going on. Okay, this is ridiculous. Okay, we've got log base x of 1 on 9 equals negative 2, which means x to the negative 2 equals 1 on 9. X to the negative 2 equals, well, that's 1 on 3 squared. X to the negative 2 equals 3 to the minus 2. X equals 3. Vitally, I'm going to make it, hang on. Sorry, talk amongst yourselves. I can't bother pausing the video. Just because that means uploading it to my Mac and then using iMovie, and then I have to export from iMovie to YouTube, and it's so much easier to go straight from this file to YouTube. Okay, question O. We've got log base x, 1 on 8 equals negative 3. You can probably see x to the negative 3 equals 1 on 8. 8 is 2 cubed, so x to the negative 3 equals 2 to the negative 3. X must then be 2. One question to go. Oh, where's my calculator? I need my calculator to show you how to do these. How's your day going? I hope it's going well. Where is it? Oh, there we are. Because you haven't used the log button in your calculator before. So this is exciting. It's a whole new world. So we're doing the log base 10 of 2. Now, there's a reason that all of these are log base 10 or 10 to something. That's because that's one of the only things your calculator can do with logs. Logs are really complicated, like to calculate, if it's not a whole number. Like these ones were fine because it was always a nice whole number and we knew it. But you'll see. Because, for example, if you've got log base 10 of 2, they're trying to figure out 10 to the something equals 2. Can you figure that out? No. People have done the maths for us, and then that's been stored in the calculator, and the calculator figures it out for us each time. Oh, let's have a look. Here's my calculator. This button is automatically log base 10, okay? The one that just says log. So if we're trying to figure out the log base 10 of 2, you just do log 2, 0.3010. But it said to do 3 significant figures. Gone. Okay, I'm not going to show you doing them each in your calculator. You're going to have to rewrite them. If you've got, oh no, you can actually do 10 to the 0.301. Now, 2 ways to do that. You could do 10 to the 0.301. Or there's a see above log how it's 10 to the something? You can do that straight away. Just saves you some time. So that was 1.9998618.7. We want 3 significant figures. Now, whenever they're talking about 3 significant figures, they want 3 figures from the first, like, actual non-zero figure, which in our case takes us, we would round up, so it would be 2.00. Okay, E, 10 to the 0.5. Doesn't matter which way you do it in your calculator. 3.16. FG, log base 10 of 3.16. Guess what we're proving? 3.16. So see how that log base 10, we just use the normal log button, 3.16, 0.499687 is 0.50. 0. That's 3 significant figures. And FGHI, log base 10 of 0.7. negative 0.15. So if you'd done 10 to the negative 0.155, it should have come out as approximately 0.7, which is what we're doing next. HIJK. So we're doing 10 to the negative 0.155. Let's see what that comes out as. Bet it's nearly 0.7. Yes. 0.69984, three significant figures, 0.700. Oh, sorry. JK. Oh, that was the last one. Thanks for sticking with me. I'm sorry that got so gross.